It's a great honor for me to be here at the Empire Club of Canada today, which is arguably the most famous and historically relevant speakers podium to have ever existed in Canada. It has offered its podium to such international luminaries as Winston Churchill, Ronald Reagan, Audrey Hepburn, the Dalai Lama, Indira Gandhi, and closer to home, from Pierre Trudeau to Justin Trudeau. Literally generations of our great nation's leaders, alongside with those of the world's top international diplomats, heads of state, and business and thought leaders.
It is a real honor and a distinct privilege to be invited to speak to the Empire Club of Canada, which has been welcoming international diplomats, leaders in business and in science and in politics. And when they stand at that podium, they speak not only to the entire country, but they can speak to the entire world.
Good afternoon, fellow directors, past presidents, members, and guests. Welcome to the 117th season of the Empire Club of Canada. My name is Antoinette Tumilo. I'm the president of the Empire Club and your host for today's virtual event celebrating Poet Technologies, Inc., Making Money in Global Photonics Industry, featuring Suresh Venkatesan, Chairman and Chief Executive Officer, Poet Technologies. I want to take a moment to recognize our sponsors who generously support the Empire Club and make these events possible. And we have many sponsors today. Thank you to our sponsors, IBK Capital Corp., Toronto Star, Creative Ventures Limited, Providential Pictures Inc., Golden Birches Resources, KJ Realty Inc., Emmanuel Family, From Development Inc., Arc Pacific Resources Corp., Randall and Bruce Reed Brothers, Canadian Nickel Company, Viale Media, BMG Group Inc., Orcrest, Cobalt Blockchain, Noble Mineral Exploration Inc., Spruce Ridge Resources Limited, and New Age Metals Inc. I told you there were lots of sponsors. But we also have seasoned sponsors. I want to thank the Canadian Bankers Association and Waste Connections of Canada. And I do want to thank our event partner, VVC and livemeeting.ca, Canada's online event space for webcasting today's event. Now, before we begin today, I have a few logistical items to share. First, if you're finding your internet feed is slow, please see below and click the Switch Streams button. And don't hesitate to press the Request for Help button if you are experiencing technical difficulties. Our team will be happy to assist you. It is now my pleasure to call this virtual meeting to order. Today, we welcome Poet Technologies key management and board members who include Dr. Suresh Venkatesan, Chairman and CEO, Vivek Rajgaria, President and General Manager, Thomas Micah, Executive Vice President and CFO, and Kevin Barnes, Controller. Poet is a Canadian company incorporated in the province of Ontario, which trades on the TSX Venture Exchange under the ticker symbol PTK. Now for a little market overview. Current semiconductor technology in today's world is based on the use of electrons to form electronic circuits. While electronic circuits have led to the technological advancements we enjoy today, the key driver, Moore's Law, is being challenged both in terms of achieving higher performance and increasing scale. Photonics is the use of light through fiber optic cables as the medium for data communication and processing to enhance and further contribute to the growth and proliferation of semiconductors. Compared to copper wire, photonics can transmit 100 times more data per second, consume 10 times less power, and produce 10 times less heat. Therefore, laser-generated light is fundamental to the ever-growing sensing, computing, data, and telecommunications markets. However, conventional approaches to photonics are both expensive and slow, as most modules are built individually, eliminating the possibility to scale. POET's breakthrough technology enables integrated photonic chips to be produced at the wafer level, achieving the lowest cost of integration combined with unparalleled scalability in production. Now, I would like to take a brief moment to introduce Dr. Suresh Venkatesan. Dr. Venkatesan is an industry veteran in semiconductor technology development with over 22 years of experience. Prior to joining POET Technologies, he was Global Foundry's Senior Vice President of Technology Development. He also previously held various leadership positions with Freescale Semiconductor in Austin, Texas. Dr. Venkatesan holds over 25 US patents and has co-authored over 50 technical papers. He has a Bachelor of Technology in Electrical Engineering from the Indian Institute of Technology and a Master of Science and PhD in Electrical Engineering from Purdue University. Dr. Venkatesan, over to you, and welcome to the Empire Club.
Thank you. Thank you, Antoinette, and thank you, everybody, including the sponsors, for giving me the opportunity to be here today. What a year it's been, right? It's almost a year since, I'd say the first week of January, I was actually in China. We were working through the beginnings of, what today is our joint venture with Sana and IC and Super Photonics. So that was the first week of January. Almost exactly a year ago, I just got back from Singapore, and I haven't, left my home since, in a sense. So this is a great opportunity to try to reach out, obviously myself via this medium that we've gotten really used to. Oddly enough, I was commenting to Mike, it's also been my first opportunity in a year to actually pick out a tie and wear a dress shirt and jacket. So anyway, I think what I want to do is to spend the next 30 minutes or so broadly talking about our innovation, inventions in general, our innovation, why we believe we're going to be able to make money in the photonics market. I know the title of this talk was Making Money, and it's somewhat anachronistic, but I think we're close to putting products out, and so I think it's relevant in the context of what is it that we're doing that would allow us, in a sense, right, to make a disproportionate amount of money. And as you bring more value to the equation, that's what typically happens in this industry. So, that said, let's go ahead and queue up the presentation. I would spend about 30 minutes talking about what we're doing at POET, and then I think we'd open it up for questions, and then end the session on that note. So what POET is doing is effectively developing what we call a unifying platform for chip scale hybrid integrated photonics. And as I go through the presentation, every word has meaning. Okay, unifying in the sense that we're combining the benefits of multiple platforms that have existed in the photonics world over the past few decades. But we're unifying them in a means that hasn't yet been done before. When we talk about chip scale integration, it means wafer level processing. When we talk about hybrid, it means dissimilar die, right? So we're not relegated in a sense to using a class of die or a class of chips or a class of solutions, but we have the ability to hybridize them and integrate it, which means many in one, right, in general, and photonics, and that's our primary application. So every word on the slide means something relative to what it is that POET is doing and what it is that differentiates POET from potential other solutions that might exist in the market today. All right, so I think the premise fundamentally that drives success, for companies like us, especially in this industry, is invention, innovation, and I found this particular statement that Jeff Bezos just made in a letter to his company employees as he stepped down from CEO particularly relevant. I mean, which is invention is the root of our success. And if you get it right, a few years after a surprising invention, this new thing has become normal, right? People yawn, and that yawn is the greatest compliment an inventor can achieve. Which basically says, look, what we're doing, especially in the context of disruption, at the point that it is disruptive, can seem strange, new, hard to adopt. And, over time, it just becomes the way things are done. And what we want to try to do at POET is fundamentally change the dynamics of how one thinks about assembling photonics devices and change it such that it just becomes the norm. People are not talking about it, a decade from now. It just is the way thing is done. And that's the premise of invention. That's the premise of innovation. So, I found that statement to be particularly powerful in the context of what POET, is about and what we're doing. So if you were to just track invention over time, and I just take one particular vector, let's just talk about history of recorded music. I think it started with phonographs back in 1890, right, and then moved to long LPs, for us who actually remember those days. That was in the 1950s. Then moved to 8-track or spool tapes in 60s, then cassette or the compact, right? That was one big change. And if you really talk about the ones that are major in terms of the impact and that it had on people and the impact it had from a technology perspective, that transition to compact was important. But probably the most fundamental change was the Walkman, right? That was in the 1980s when Sony put it out. And why was that so fundamentally different? Is because it changed the way you enjoyed music. Rather than sitting in a place, either at your home or wherever, you now had music on the go. That was fundamental. It was a lifestyle change, right? It was a change in how you did things, how you appreciated music, how you enjoyed it. There was no fundamental other innovation outside of miniaturization that enabled it, but that change in lifestyle is what made that innovation so dramatic in terms of what happened later. Then came the CDs, and then eventually you move to the digital media, right? And then finally, we're now kind of in this wave of streaming music. So in this wave of streaming music, you don't think about, in fact, the other day I was trying to download software on my computer, and I had a DVD, but none of my devices had a DVD drive on it, right? And so, everything has now migrated away from this hard media to streaming. You don't think about it, but at the time you're making these transitions are hard. And so when people talk about POET and what we're doing, and where are we in the cycle and what it takes, and we'll talk about some of that stuff in this talk, is we are making a change. We're making a transition to the status quo. We're changing decades of how things are done. And so, that affecting that change is extremely rewarding, but also difficult. And that is the journey that we've been on. And we're, happy to note that we're, close to putting out products that would finally break this myth that it can't be done, and that there are new ways of doing things that will, we believe, ultimately become the norm in the industry. So with that, our vision, which is critically important because it aligns us as a company, it aligns us with our suppliers, it aligns us with our customers, is to become a global leader in chip-scale integrated photonic solutions. And we're going to do that by deploying what we call our optical interposer that we have discussed before, which provides a seamless ability to integrate electronics and photonics. So, integrating photonics is the really important piece. The ability to co-integrate electronics comes for the ride, and so that seamless ability is what our vision is. It's why I joined the company to drive integration in photonics, and we stay that path, right? That has been our guiding vision in the company. And while the medium of integration may have changed since I first joined, the end is still the same. And our mission immediately is to deploy products using our optical interposer solution for the high volume data communication segment of the market. So what is photonics? I think, Antoinette did a fantastic job in the beginning, giving an explanation for why photonics is important. Communicating with light is faster and consumes less power, ultimately. And that is, and more of the communications medium would like to be using light. If we could get the cost out of the equation, have the ability to scale it, all of the things that we want to do with our optical interposer technology. So photonics devices create with lasers, detect with photodetectors, and manipulate either in free space or through waveguides in the case of light. Laser light generated is fundamental to sensing, computing, data communications, telecommunications, all the biggest trends in computing today. And the ability to move the power generated by the laser through waveguides, through a detector chain is critically important. And while it might sound simple, it is not, right? Which is why people have been struggling through this process for decades. And we believe that we have finally, through a good confluence of semiconductor technology, as well as some innovations that we have done in the way lasers are manufactured and assembled, that we think we can break through, how that entire assembly process works. The primary use of photonics is being driven by, of course, the massive explosion of cloud, but also a growth in artificial intelligence, as well as the adoption of 5G and edge networks. All of those are basically driving a significant growth in data transmission, data consumption, data creation. And as you generate more and more data, the need for optics becomes more. Initially, it was basically subterranean optics or sub-oceanic optics back in the year 2000. But now it's optics everywhere. I mean, we have fiber optic cables, honestly, in our home, transmitting across rooms. So, we know that the trend is moving to increased use of photonics devices. And that's why we believe photonics is really important, both today as well as in the future. Photonics transceivers, which are the primary device that we're talking about in terms of disruption and in the assembly process, are those devices that convert these electrical signals into light signals and then back to electricity again. So the way data is communicated using light is that the data is first transmitted electrically to the edge of a server, as shown in the picture here. There it is converted into light, transmitted through an optical fiber, and then it is decoded back at the other end. And it is that segment of communications, which can be anywhere from 100 meters to several kilometers long in data centers, has to be done optically, because at the frequency and speed at which that light data is being transmitted, there is no other mechanism to transmit that outside of optics. So that's what photonics transceivers are about, and that's what POET's working on. Now, what is the issue? The issue is that over the past 2 decades of photonics transceiver manufacturing, the conventional approaches have now proven to be very expensive and very slow. They are typically, multiple layers of subassemblies that need to be created in forming the fundamental building block, which is this optical engine that goes into a transceiver. In the case of existing solutions, you start with a laser chip, you first mount it, create a laser subassembly, then that laser subassembly becomes a transmit subassembly. Similarly, you do that on the receive side, create another subassembly, there's a housing subassembly. It is insane, how complicated that process is. But nevertheless, that's the process that's been used for the past 20 years. And so there's always a resistance to change, and there's also a burden of proof that an alternate way of doing things can, in fact, be quite as competitive. Uh, but this process is not scalable, okay? It's expensive just because of the number of steps involved. No matter how many people you throw at it and how many garage shop operations you set up to create all of these sub-assemblies, at the end of the day, you consume time, you consume capital resources. They're expensive to build, and far more importantly, it's very difficult to scale. So when we're talking about really high volume applications and being able to cross that chasm from building 1 million units a year to 100 million units a year, I mean, that's a degree of scale increase that you can't go linearly. And there needs to be a super linear way of addressing it, which is where integration comes into play. This is not new. I mean, people have talked about integration since the early 2000s, but it has not yet been fully implemented, despite many companies working on it for, a couple of decades. I personally have been working in this field since the early 2000s with silicon photonics. I've known of some of the issues that are there. And what we have done at POET is to try to architect perhaps a different way of looking at the problem, rethinking, in a sense, how assembly ought to be done, and coming up with a solution that is not only achievable, but also scalable, and scalable both in terms of performance as well as scalable in terms of cost. So why does integration matter? I've covered some of that already, and especially in the world of photonics, integration matters a lot. And particularly integration in the assembly or packaging aspects of the photonics devices matters a lot, because much of the cost of photonics is in the assembly process. It's in assembling the lasers, ensuring that the laser light is coupled correctly, that all the light from the laser is usable and it's not wasted along the way, and ensuring that the laser maintains its fidelity as it's being packaged, that it doesn't deviate from its original specifications as it's being packaged. These are extremely esoteric components. They are finicky. Even among the class of semiconductor devices, optical semiconductor devices are hard because they use nonlinear physics in the way light is being generated and emitted. And so dealing with these has been difficult, which means the packaging has been extremely difficult and esoteric and expensive. And what we're trying to do is to kind of demystify that process and apply more conventional semiconductor technology to that process. There's obviously skepticism, and which is why we're going through these multiple prototypes and validation processes to get past that and to get to a point where customers actually say, aha, this can be done, and we're moving down the path of integration. So our approach to integration is not dissimilar from what others have done in like spaces. I mean, in this particular example, it's an iPhone or any smartphone for that matter. And here the integration is in functionality. So you can integrate a camera, GPS, and so on and so forth. For us, it's the integration and components, and so that's one aspect of what we're doing, is integrating hybrid components together into a singular chip. The other aspect of what we're doing is to create a platform. A platform is critically important when you're trying to access multiple applications, because you really don't want to do a grounds up design each time to address a new product or a new product portfolio. There's always going to be some extent of redesign required, but if we do it in a way where that redesign is minimized, one has the ability to proliferate known solutions across multiple segments, either within a similar vertical or across multiple verticals. And so we've taken a fair bit of time up front to develop it within the context of a platform to enable that kind of a reuse to occur. So in short, POET is doing for photonics what semiconductors has done for electronics, right? We're achieving lower cost, higher performance through device integration and wafer scale fabrication. It sounds so simple, but applying it to photonics has not been. And we believe that we are at the cusp of this breakthrough where we can, actually put products in customers' hands that have been built a very, very different way than people have built these products for the past 30 years, right? It is meaningful, and it's significant. So the optical interposer platform, like I talked about, is a unifying platform. There have been platforms for integration within the world of photonics that have existed, particularly for passive devices, or interposers have existed, micro-optic assemblies have existed. But what we've done at POET is figured out a way to unify the capabilities of these platforms into what we now call the optical interposer platform. So we have the ability to address many market applications, whereas silicon photonics is typically relegated to a few. And we do believe that we have the ability to address a very wide range of applications with our technology in the context of it being an overall unifying integrated platform. So I think the key is, platform to products. I think, a product platform is not a product, right? So what we have done so far is develop the platform. We are now in the process of converting that platform into actual products. I think we've made multiple announcements with tape outs and, imminently in the process of being able to place these products in the hands of customers for evaluation and feedback and so on. But it is a collection of common elements. We do expect that most of our products will have a set of common elements, and then there will be new products that have potentially different elements, but with a common backbone. And so I think we expect, therefore, to, you will see that in our roadmap as well, is that, we go from kind of 0 to X number of products almost simultaneously, only because we've kind of developed it in the context of a platform, which then allows us to proliferate that platform across multiple segments. So what are we doing? I mean, we're rethinking conventional photonics assembly. I think in our standard assembly processes, just, gives you a sense of how much equipment, how many steps are needed. And what we tend to do is to basically move to a scheme where, due to wafer level assembly and the integration of all of the passive components into that wafer, which we call the optical interposer, we reduce the number of components, we reduce the amount of capital, we reduce the amount of time. I have been to some of these operations in China, particularly, because that's where much of this gets done these days. And it's basically wall-to-wall equipment and people, and each person is sitting and handling this assembly process. And it's extremely tedious, time-consuming, and expensive. Now, of course, over 20 years, this has become an operation that is, people just know how to do it, and you can almost turnkey one of these operations. You from start to finish, you can place a full factory like this in a year. But it doesn't scale, beyond a certain point, because there's sufficient fixed cost, just doesn't go away. 5 years ago, for example, people talked about 100 gigabits per second, it needing to be at $100, $1 per gigabit per second was kind of like the mantra that was being used. And, several people went about going doing, 100 gigabits per second. And, and today, the prevailing price in the market is still about $120 to $150 per module, depending on who you talk to. So it never actually got to that 100 gigabits per second point. And we know that with our technology, we can break that $100 barrier, right? We can get actually quite a bit below that $100 barrier. So that's meaningful. And that is because we eliminate all this stuff that you're seeing on the screen, right? And we migrate to more of a wafer scale capability with fewer tools, fewer CapEx, But it is a very different way of doing things. And I think one of the challenges we face, and it's a question I get asked all the time, which is, hey, but I've already placed all of this infrastructure, I have all of these tools, what am I going to do with it, right? And so that kind of harkens back to, that music analogy that, at the point of disruption, it is sometimes painful, especially if the folks that are kind of used to doing things a certain way. But over time, it becomes the new normal, right? And that's what we hope to and expect to develop as we proliferate our technology in the market. As I discussed, the fundamental building block is what we call this transceiver chip. And so we are rethinking the transceiver itself. So of course, applying this interposer concept, applying the wafer scale capabilities, we're effectively able to devolve, right, all of these many sub-assemblies and many components that exist into a single chip kind of implementation, a single chip implementation that is capable of up to 50 gigabits per second per channel for 400 gig applications. The same basic technology is also capable of 100, 200. It's a very scalable platform. And of course, there's difficulty. I mean, we're talking cutting edge, not even cutting edge, bleeding edge in terms of what we're trying to do. But we believe that the simplicity of the capability and the integration is what ultimately is going to make this a very successful platform. We use, simpler bill of materials, reduced steps, reduced using standard assembly technologies, and something that is scalable in terms of capital, in the sense, it's super linear when it comes to number of devices for a certain amount of capex that has been invested, which is what makes this attractive relative to the more straightforward linear kind of approaches, which is, oh, you need 1,000 more. Okay, let me put another station with another person and another tool, right? And we need to break through that mold if this is going to be an attractive technology for high volume. So as a consequence of developing this capability, we have now designed, and it's in the fab getting productized today, what we believe is the world's smallest, lowest cost 100 gig optical engine, right? And we can put these lasers, photodetectors, monitor photodetectors, multiplexers, demultiplexers, power taps, all within a 9mm by 6mm. It doesn't, you could probably measure a 9 by 6 on your fingers. It is pretty small. But within the scale of what we're talking about, you can fit 4 of these inside the space that is today occupied by 1, right? Which is huge. I mean, there are some customers that we're talking to that want to leverage the fact that we can make it quite this small. And leverage that form factor by doing some things innovative in the module that haven't been conceived about before. And that's what this innovation is, in a sense that for different people, it could mean different things. For some people, it could mean, oh my God, I can get to sub-$100 for a gigabit, 100 gigabit link. For other people, it is, oh wow, this form factor is so small, I could do something that I couldn't do before. And we're exploring that with multiple parties as we start proliferating our capabilities across kind of the value chain of customers, and we're seeing that resonate, which is it could be different things to different people, just because of the dimensions in which we bring value for the customers. So what are the benefits of the optical interposer? At the top line is cost. We think that the way we go about doing things, when scaled to full volume and running, the way normal semiconductor assembly runs, which is very high yields, we expect these module costs to be, substantially less. I mean, these are not, incremental changes in pricing, which is what people normally see as an attritional rate of 3 to 5% a year. We're talking about a fairly large one-time reduction, right? And once you kind of taste that fruit, it's kind of hard to give it up. And we need to get to that point, because I think till such time as that happens, people are going to be very happy doing things the conventional way, right? It's lower capex investment for module assembly and test. I've discussed that. It's chip scale packaging, which is wafer level integration. And it's a hybrid planar technology, which allows us to use dissimilar components. And for different applications, that could be of value. I think today, people don't know what that means, because they haven't had the luxury of being able to do it that way. And I think there's some education that says, hey, for this particular application, perhaps you can use this device instead of this device, because as far as we're concerned from an interposer perspective, it's a don't care. So let's pick the best devices for the applications. And that's that flexibility that we think is going to be critically important going forward. So over the course of this quarter, and I think it's one of the reasons why we've been boisterous. I think we've come out in a sense and have discussed this openly. Is we've generated a fair number of industry firsts. I mean, which is saying something, right? We've been at this for about 3 years. I think we conjectured about the interposer in 2017. We announced the first platforms in 2018, or the concepts. And so we've been at it about 3 years, okay? And in 3 years, we've generated data better than people have in 20 years. And after billions of dollars of investment. Not that I couldn't do with $1 billion of investment, but the point is that, when you think of doing things differently from the ground up, you can make disproportionate progress, which is how innovation works. That's how invention works in general. And that's what we've done. So we've got the industry's smallest transmit receive optical engine. We've got the best coupling efficiency, and I've discussed this in previous meetings as well. Our losses through our system to usable power is the highest you can get in any photonics assembly, even done the conventional way, right? We've also demonstrated the first directly modulated laser that has been flip chipped and assembled at wafer scale. And that is important because, A, nobody's done it, and B, doing that opens up the door for 100 and 200 gig applications that use directly modulated lasers. At 400 gig and beyond, we're using continuous wave lasers, but at 100 and 200, which is the biggest volume of the market today, requires DMLs. And so it's really critically important that we've been able to achieve that milestone, which is why that was a big announcement. And it had the right effect. It resonated the most as well with the investors, with the group, the customers. I mean, it was a meaningful achievement for us to be able to get there. And of course we've that comes along with the full integration of the multiplexer demultiplexer that we've talked about for multiple years now. It's taken us a fair bit of time to really get that level of performance that is needed for these extremely stringent requirements. And finally, we do believe it's the only one of its kind today, a fully hybrid photonics assembly platform that we believe, at least intellectually, you can project out and say, hey, all of these components work. You can project intellectually out and say, this can be done. It can achieve these levels of cost. And yes, the burden of execution is on us to be able to do it. But we believe that we've gone through all of the key requirements. People ask me all the time, why are you in this never-ending prototype loop? So I thought it'd just be important to kind of educate and kind of bring back to basics in a sense. What does a design process look like? I mean, a design process starts with kind of understanding what the market requirements are, defining the technology, and then innovating, right? So the entire innovation piece, went about in the 2018 timeframe for us as we kind of re-architected what we believe is integration in this space. And then we've been in this prototype world for a while. But even in the physical prototyping concept, there's always a proof of concept prototype that basically says, hey, look, I've validated every individual block, and fundamentally the proof of concept has been ticked, right? And we did that about a year ago. And then, now we're kind of in this functional prototype demonstration phase where we're able to articulate, it's the world's best this and industry's best this. These are functional, meeting specs, but not completely meeting all of the requirements. They're functional. And now the next step is, alpha, which are what in this particular slide says golden samples, dry run prototypes. These are basically alpha samples. And that's what we're in the process of doing. We taped the products out late last year, and we're running through, the fab over the course of the next couple of months. Those are the ones that go in the hands of customers. So far our engagement with customers are data-based. And we get into the point where people actually have these golden samples and prototypes, which then once reviewed and approved, go into production. And so that's the final phase, if you will, of this prototyping we're in. And I know, several investors have asked me over time is that, what is with these prototypes and samples, and we tend to intermix these terms, and for us it's easy. We're in the industry, we know, we've kind of gone through this process many times, but I'm trying to demystify this in a sense as to where we are in the final stages of culminating, if you will, this entire ideation innovation process into something that's going to generate value for customers, and it's going to generate value for our shareholders, and it's going to generate value for the company. So our product rollout strategy remains unchanged. It's a scalable optical engine platform for multiple frequencies. So these are the modulated laser-based products, which are 100 gig and 200 gig. And then we have the CW laser-based products, which are 400 gigs, starting with the receive engines, and then eventually moving to the modulated engines. We expect over the course of the next month to be able to make some announcements around partnerships around 400 gig. I think most of you know that we make the optical engines, we make the lasers, but we are partnering with other parties on the modulator. But because it's a platform technology that is hybrid, we have the flexibility of multiple partners for the modulator, and we expect to be working through that process over this next quarter. So our roadmap remains unchanged. I think we're kind of in this alpha sample phase. We expect to get into production by the end of the year. On the 100, 200 gig, we expect to be in production by the end of the year on the 400 gig light engine, as well as the receiver for 400. So this is kind of one of the advantages of the platform, is that we do expect readiness in terms of being able to ramp it in manufacturing in that period of time on multiple products. Of course, we can't do that with the skeleton crew that we're in today. We're happy to announce that we've closed this round of financing with support from some of you all on this phone call. And it's important because we need to scale this company. I mean, we can't be in this 20-person R&D mode and expect to generate the kind of revenue that we believe we can. I mean, it requires the company to scale. I mean, we've got to mature. We've got to be a player in the industry commensurate with the kind of technology that we're talking about. We've talked about the joint venture with Sanan. The joint venture with Sanan provides manufacturability and scale. And finally, the opportunity. I think we're working on data transceivers for the data center market today. We'll be working on 5G. We've already announced, a co-packaged optics solution, especially in the artificial intelligence space for optical computing. Each of these opportunities is a fairly sizable opportunity for us, because what we are doing is fundamentally revising the way photonics packaging ought to be done. It's like saying, you've got a fundamental packaging technology. Well, where can you apply it to? Well, everywhere, right? But where are the ones that we think we can add more value now and in the future? These are the verticals we believe we can, and we believe we can make, meaningful penetrations in these vertical segments. But of course, our focus initially is transceivers for data communications. So in summary, I think POET, we've successfully, transitioned our company from technology development to products. And we're now imminently in this final phase of prototyping, getting golden samples built, engaging customers with golden samples that meet their requirements. What we have seen from our functional prototypes are meeting are exceeding our expectations in many cases. So we're extremely pleased to see that. We have established our manufacturing arm, which is Super Photonics, and we believe this company has the opportunity to build a significant revenue business, which is what much of us want this company to do. And I think several of you have been extremely supportive in our mission to get there. And I'm extremely pleased with the progress that we've made over this year. We hope you see it as well as we communicate this message to you. And I look forward to your continued support as well. Thank you.
Thank you. As we're all sitting in our homes, we are all very hopeful that you are able to speed everything up for us so that we don't have the challenges we have on internet and all of that, and can send huge amounts of data back and forth. So we have lots of questions being directed, and we've got a few minutes. So I will address some of the questions to you for a moment. I have a question from Wayne White. What initial activities or early milestones have been achieved to date on the JV with Sanan?
Yeah, I think there's been a fair bit of activity on setting up the JV. I think the infrastructure in terms of the building, the space, that's all been done. We've hired the management team. The board has been established, and I think now we're kind of in the process of acquiring capital. As you know, the JV is set up such that the capex is procured, from Sanan. And so we're now in the process of placing POs and buying capital. We expect the JV to be functional in terms of being able to do the assembly, et cetera, from about the second quarter. So till that time, we're still working with several subcontractors to do the work we need to do. We expect to continue that process through such time as we generate these alpha samples. It's critically important we do that, so we don't want any disruption there, but we would expect that transition to occur around the second quarter of this year.
Great. Another question from Russ Frum to follow on that. Can you frame what POET believes the ultimate revenue potential is of the JV?
Well, I think the revenue potential, as we articulate, for the joint venture right now is set up primarily for 100, 200, and 400 gig data communication. So obviously the revenue potential there is limited to that market vertical because that's what the JV is chartered to do. Of course, we have the ability to expand the JV into multiple verticals and increase its revenue potential. But for the market segment of 100, 200, and 400 gig data communications, the revenue potential for us collectively is about $250 million.
Okay. Phil Emmanuel wants to know if you could provide some insight into the scope of current discussions with prospective customers.
Yeah, I mean, look, we've we're hampered, but because we can't travel and visit with them, we think it's far more meaningful and powerful to be able to do that. But we've had engagements with several customers since the beginning of this year because we've generated the data package that we believe is important to have these engagements. I think, when you're early in your development, you kind of limit your visibility to a few. As you kind of progress through your development, the burden of data is more. And so I think now we've generated the data package necessary to engage meaningfully. And we've been pleased with the take up. I mean, I think there has, I think a couple of years ago we'd made this announcement with a large module company, AC Link. Obviously, we've had some delays on our end, getting solutions out since that announcement, but we've re-engaged, and I think those engagements are, obviously positive. So yeah, we feel we're in a good spot. I don't think at this point in time we're going to be demand limited. Honestly, I think we're going to be. Our limitation is to overcome the ability to get samples into the hands of customers, which is a process. I mean, there's no major science that needs to be reinvented at this point in time, but we have to go through the process, and we've taped out where, the fabs are doing what the fabs need to do, and we go through the process. But I don't believe, we're going to be demand constrained. I don't think we're going to be in a point where we're searching for customers to adopt our technology. I think that's going to work itself out, thankfully.
Great. I have a lot more questions, but I think we're running out of time. But I'd be happy to forward these questions on to you and your team, and maybe you can address them at your convenience. But I would like to now invite Mike White, President and Chief Executive Officer of IBK, to provide the appreciation remarks.
Thank you, Antoinette. And thanks, Suresh, for that presentation and those questions. I was actually joking with Suresh a little earlier. I'm not in a suit. I'm usually the one in a suit, and he is today. But anyway, that's just sort of an inside joke between the two of us. Madam President, distinguished guests, and fellow members of the Empire Club of Canada, I have the distinct pleasure to express our formal thank you to our keynote speaker, the CEO of POET Technologies, Suresh Venkatesan, and to the entire POET Technologies team. It is through your efforts that the world is finally truly on a path that will be defined as the most significant advancements in photonics. Some are labeling a photonics revolution that will finally integrate electronics with modern photonics, the implications of which are astonishing. POET is uniquely positioned not only to participate on this path, but also to help mold and shape its direction. I have to thank Suresh for helping me understand the early days of this path for POET. And as we know, every journey begins with the very important first few steps. In POET's case, these early steps are essential and potentially very rewarding, as we have heard today, with greater than $1 billion of annual revenue to come. But they are just the first few steps. It's where this path takes us beyond these first few steps that has me most excited as a POET shareholder. POET is focused on 4 verticals that we heard about today, 3 of which are data centers, 5G, and co-packaged optics. They're fairly well defined and dominated by incumbents. The problems in these verticals are generally understood, and there are multiple solutions tabled to address them. Most of these solutions are early in their development, and POET's technology is both complementary and additive to these solutions, which means, as Suresh discussed, POET can participate very well with the incumbents in this landscape of co-opetition. POET's solution is simply better. It's better on price, it's better on operational costs, it's better on form, it's better on scalability. In the pursuit to this $1 billion of annual revenue over the next years, POET must first, this year, become a trusted supplier, which means having products available and shipping. This initial volley of products is very important. It puts POET on the map in a predictable and reliable way. For most young companies, this would be the grand prize. Mission accomplished. They would happily get bought out and move on to the next venture. But the management and directors of POET can see further down the road with technology that can take them there. And it's this pursuit that gets very interesting and offers a glimpse into a future POET can make for us. Artificial intelligence and edge computing markets will be massive in size. By 2025, there could be an estimated $48 billion worth of new market revenue for deep learning chipsets for AI and edge applications. Photonics integrated with electronics are key to this future. They are essential for these markets and will usher in the wonders and conveniences of the future. It's like trying to envision the desktop computing, desktop computing during the formation of Intel back in 1968, or the conveniences of the internet in 1995 when we were all still dialing up, or the smartphone in 2000 when we were still using flip phones. We kind of know where we were headed back then, but there was nothing defined. It was there for the taking by those who were willing to take it on. And I believe POET will play an essential role in what comes next. Think of it, and it will likely be enhanced. Made smarter, vehicles, wearables, homes, commercial buildings, health monitoring, traffic, electric grids, water systems. The list goes on and on. They will all be enhanced, smart, autonomous. What was once the realm of science fiction will be coming soon, thanks in part to this modern coupling of photonics and electronics, which will help enable the vast amount of computing power and data flow at the edge of these smart systems to make this possible. Soon your fridge will ask you if it should buy more milk, vegetables, and cheese. Not into that? No problem. It'll simply send it to your smartphone and you can shop in the old way. Except you won't have to check out because the store will know exactly what you have in your bag and automatically bill you when you leave. On your way home, there'll be no more fighting traffic. Systems will automatically monitor and control flow of traffic, and besides, you won't be driving the car anyway, it'll be autonomous. Going to the airport, no problem. No waiting in security or immigration. You'll be automatically scanned as you enter the terminal. It will know who you are, where you're going, what you're carrying, but sorry, you'll still have to wait at the gates. Nothing can control the weather. Anyway, AI and edge computing are necessary to make all this possible. And although that future is yet to unfold, a lot of money is being spent trying to plan it and map it, but it is not owned. It is tens of billions of dollars of new market space that is not controlled by anyone. It's there for POET and its partners to take their share, and I believe they have the technology and knowledge to do so. POET's intellectual property solves so many existing problems, as Suresh discussed today. But it's this IP combined with innovation, drive, clear strategy, and focus of management that will see POET and its partners proliferate this new territory, this new frontier, which, if successfully executed, will reward shareholders very well and make POET a household name. The opportunity to help build a technology company with this type of foundational hardware and upside potential is so rare, and even more rare in a public company. I'm very thankful to Suresh and his team for sharing their vision with us at the Empire Club today. Their future is very, very bright. Please join me in a warm and special thank you to all that have made today possible, including the sponsors, Planning Committee, Madam President, and of course, today's speaker, Suresh Venkatesan. Thank you, thank you, thank you, and God bless.
Thank you, Mike. Thank you, Antoinette.
Thanks, Suresh.
Wonderful. Can't add anything more to that, Mike, except can't wait for all that to happen to simplify our lives. So if I can just take a moment to let our audience know about our upcoming events. For Black History Month, we have 2 events happening on February 18th, Black Prosperity, Inspiring the Next Generation of Leaders. And on February 25th, we've got Black Music and its Influence on North American Music. And on the 19th, we've got Vaccine Hesitancy, Convincing Canadians the Importance of Vaccines. And on March 8th, for the International Women's Day, we're really excited to be featuring Rania Llewellyn, who's the president and CEO of Laurentian Bank of Canada, the first female CEO of a major bank. So as you can see, Suresh, our topics are very varied, and registration for all these events is free. So I hope you join us. Thank you for joining us today. And this meeting is now adjourned.